everyone, this is Tom Cherryhomes with the next video in the Amiga as a Workstation series. In this particular video, we go ahead and do two major things. First, we install a copy of MicroEMACS, which is a wonderful text editor patterned after the legendary Emacs text editor so that we can do our source code development. And it has a number of features which we'll get into, which are very advantageous for program development, especially as your programs get larger, as well as just overall a better quality of life than the screen editor that's part of Amiga DOS to begin with. So much so that Emacs would eventually be bundled with Amiga DOS going forward from version 1.2. And once we do that, then we'll take and actually write our example sine program, just kind of so we can get a feel for the graphics subsystem and everything else. So with that, let's get started. Okay, so when we last left off, we had a hard disk system here that had was nice and quick, booted up pretty quickly, but we were left with kind of this text editor here that, yeah, it's okay. I mean, you can move around, you can do basic edits and whatnot, but it doesn't support dealing with multiple files on the screen at the same time. So you find that you have to take and launch multiple ed windows so that you can take and support multiple files at the same time. And there's no clipboard integration at this point, so you can't just cut and paste from one window to the next here. So it makes dealing with piecing pieces of code together from other source files and whatnot a bit problematic, and dealing with multiple source files a bit problematic. So we're going to ditch it. Instead, what we're going to do is we're going to put in a disk that was handed to us by Commodore Amiga, the Commodore Amiga Toolkit disk, and on that disk is going to be a copy of Emacs. Let me just pull this out of the way for a minute. And we'll just kind of pull that to here. And I will go and insert that disk in the drive right now. This is basically a very early version of a whole set of tools that would eventually wind up on the Workbench 1.2 Extras disk, roughly about 7 months later. So this, again, about spring 1986, this disk comes out here, and it's got a whole bunch of useful utilities that are good for us here. We've got some of these already, but some of them have been upgraded with newer versions, etc. And Emacs is also on here. If we go to the folder, we can take a look inside here. We'll see there's a C folder and there's a trash can. And well, we've got a font editor now, so we can make our own fonts, and we've got a little free memory thing right here. This particular version is early enough that if you try to use it on a system with more than 512K of memory, it goes a little sideways. They would take and fix that for 1.2. But let's actually dig in here. It turns out we're going to need to use the CLI to see what all is on here. So let's have a little look. We'll go directly into the C folder and have a little look-see here. Well, we can see some of the things that were previously on developer disks by themselves and on like the macro assembler disk, etc., in various bits and pieces of places are now actually here on this disk, just kind of put together here. We have a copy of ROM WAC 2, which calls ROM the WAC in ROM, and we've got the disk-based WAC as well. We've got a couple of programs that concern themselves with downloading to the billboard so you can do cross-development to your Sun workstations, and so on. But the things that we're really interested in are Emacs, And maybe we'll take and copy a copy of the font editor as well. Why not? We'll just kind of put it in the, is there a tools directory here? Can't remember. No, it's utilities. I'll just put it in utilities because I can, or system. So we'll copy that. Here. Because we can. Might as well, we might use it later. And we're going to take and copy Emacs into our MicroEMACS, or just Emacs here, into our command directory, which is already assigned over to the hard drive. Now that we've got that, now we can start doing some interesting things. Well, what did we just copy here? Well, we don't need this disk anymore, so we'll just take and throw it, eject it out. And let's just have a look. Earlier versions of Emacs had very limited integration into the system. In fact, the very first port of Emacs basically just used the console device, and they did a quick and dirty port of the VT100 driver that MicroEMACS already had over to use it. The difference between that version and this version is quite remarkable, because this version, which was actually which was ported by Andy Finkel, takes the work that David Conroy did, Daniel Lawrence, and a few others that had been improving Emacs over the previous months, and added a whole bunch of enhancements and integrations into Intuition, and made it a very nice program to work with. One of those things, as you'll notice right here, is the addition of Intuition menus for common functions in Emacs. It's very nice. It also supports, if you want to have more lines on your display, it supports interlaced display as well, which is very nice. Again, this is something that is something that's very good. It's worth noting that at this point there were no flicker fixers, so if you could put up with the flickering from interlaced mode, you would be paid off with doubling of your resolution. We'll just turn it off for now. So now that we've got this here, let's do a few small quality of life enhancements here. We're going to quit real quick. Okay, that's fine. Sure. Nah. There's not really an editor. There's not really an editor per se that's set up here, and just clicking on it wouldn't be all that useful. So we really want to continue using it in the CLI, but we would like to take and make a couple of include changes here and add some folders so we can actually start doing some work. So the first thing we need to do with Workbench, if you want a drawer that can be used from the Workbench here, you'll notice that when we look here, there's no facility for creating a new folder. What you have to do instead is you have to duplicate your empty folder. And once your empty folder is created, move it where you want it, rename it to what you want it to be. In our case, we want a workspace so we can do our work. Sure. Rename it. There it is, ready to go. Let's go ahead. I'll just snapshot it so it'll wind up there next time. Okay, great. Now we've got a workspace folder. And we can do the same thing for our first little program that we know we want to put together here. And we'll go ahead and make that as the sine program. Move it over. Okay. So now we have our little sine folder. It's here, ready to go. Now, you may ask why you would want to do this, especially if you can just do everything in the CLI. And it's a valid concern. But these little things that you can do ultimately add up later to basically make using your environment that much smoother if you do a little bit of work up front. It's kind of nice in that regard. So now, if we take that, we have that. Now we can basically take, and I'm going to take and borrow an icon here from Notepad, and we're actually going to abuse a utility here just so we can have an icon, because Notepad has an icon built into it when you save a file. We're not going to really do anything with it. We're just going to take this, we're going to save a file, and you can see, especially early on, these early Amiga utilities really didn't have much in the way of requesters and the like. So we'll go ahead and disk workspace sine, and inside sine we go ahead, we're just going to make it as sine.c. And I'm going to show you what happened here. If we go into the workspace and we go into the folder that we've created, you'll see that there's now a document here that we can use. Cool, huh? Okay. Now, however, if we actually take a look at the information on this icon, we'll see that it takes and bounces itself out to sysutilities notepad. Not very useful in this case. So what we really want to do, we want to take and have it called via Emacs. Go ahead, save, sure. And now if I run here, you'll see it's right here, we're in Emacs, and we'll go ahead and just kill this line right here and save this file right here. But you can see now we can take and just edit our source code file entirely by just clicking on it, going into MicroEMACS, right where we need to go. Couple of other things that we want to do, just a couple of small little tweaks that we want to do. We're going to go ahead and go back into system folder real quick. We'll clean up a little bit. Make our little utilities folder just a bit larger so it can hold our font editor. And we'll snapshot it. Boop. So there we go. Okay. Oops, need to do that again. Accidentally started it here. Oop. Definitely some weird bugs there, but that's okay. Whatever. We'll just snapshot it. We're not going to use it yet. Save. Done. Boop. Okay. So now sine is ready. We're good here. And I will go. I keep coming. Sorry, guys. I got caught up in trying to get the font editor dealt with there. We want to make a couple of changes to our startup sequence. That actually happens on DF0 because we initially do the boot before it does the cutover. I want to add a couple of things here. I want to add an assign for include. We'll see why in a bit later. I want to add an include for a new folder for the workspace folder that we just did. And I want to add an assignment for examples, which is the lattice examples that we copied over, which contains, among other things, one window. Okay, great. So now that's in place. Save the file. And now if we take and boot the result, which thank you to my watchers who have graciously informed me that WinUAE has a few alternate key bindings for some hard to reach Amiga keys, and now I'm able to take and warm boot my system without having to go through the rigmarole of going through and swapping out all the kickstart disks. Okay, so now that's in place. And we got our workspace folder here. Everything's assigned. And now if you'll find that if I go to my CLI, I can go straight to my workspace folder. I can immediately dump into include, which is very helpful if you're looking for something very specific. Say you're going to use the search command and you're looking for search include for, let's see, think of something good here. So it makes it very easy and effective to take and look for where things are in certain header files, etc. And it helps, yeah, see, there it is right there. Line 474, smart refresh. So there we go. Okay. And now that we've got that basically set up, now we can start actually using the little environment that we prepared for ourselves. Go into our sine folder here. And we bounce into Emacs. Emacs gets its own screen, which separate from the workbench, and it's a 2-color workbench screen, so it works really fast. No color highlighting or anything like that, but it's fast. So just a little bit of some comments up top. And now we'll start putting in the bits and pieces that we know we need. Well, I can basically just go through and type them out, or I can use a bootstrap and use the includes that I know are in the one window demonstration program to help me out and get me started that much faster. Thankfully, Emacs has the ability to take and split the screen up into multiple slices, so you can look at multiple files at the same time. We're going to take an XV to visit a file. And since I made this assignment, I can just go examples, one.window.c, read the file in, and here we go. We're now just looking at it. Here we go. Bam, bam. And we have all sorts of nifty little defines and things that we need. But here we have the includes that we know we want to use. Cool, huh? Well, we can take and set a mark. I need to see how to take and enter this particular keystroke on this keyboard. And we can basically just pull down all the includes here, and we'll just take out the parts we know we don't want. We'll take that, we'll just copy the region, and you'll see right here, since we're in this first window here, if you take and click outside of the buffer here, it will scroll down to the next page. What we want to do, even though you have mouse control inside a particular window here, to get to the other buffer, you actually need to take and do Control X, Control N, or so yeah, and we'll go ahead and just yank it in, boom. And at this point, we can kind of go through and we know some things that we know we don't want to use here. We don't need to use the key map or the timer, so we can just kill these lines. We don't really need the DOS library either. We're not doing anything we're not doing anything with it. Actually, yeah, yeah, DOS text. We don't need disk font. We do need intuition. And since these are actually in our include path, you can use either quotes or you can use the greater than, less than braces to take into our includes. But we're just moving it over here. No problem. Bam. This works just fine. Now, another thing that we absolutely need, since this is not ANSI-C, but it is K&R C, we actually need some prototypes. And if we come back over here, we're in our second window here. Let's just look at our buffers. Is it still here? No, it's not, because I visited. Here we go. You can see there are some externals, and believe it or not, we need these here because we're not returning integers from these functions. We're returning pointers to structures that need to be properly maintained across the move. So we need externals for open window, and really that's it. We're not using anything else. We're not creating any message ports because we're not communicating with other devices like the console or anything. So we really just need open window. We'll go ahead and move it over. So now that's good. Now we can come down here and you'll start to see some other bits and pieces of things that we know we need. Well, we need a new window structure. Sure, no problem. We'll go ahead and start typing this out for what we know that we need here. Let's see. Boom, ba-do-ba-doo, set mark. Actually, I don't want all these comments here, so I'll just take and, yeah, the way they did this was just wrong, but I'll just clean all this out. You can see there's a lot of just comments, example bits and pieces, but it's very helpful for what we need to do here. So let's go ahead. Copy region. Move it in. Okay, great. I will remove these comments. There's a couple things here. We figure out pretty quickly if we take a good look, for example, in the intuition manual. There is right at the beginning of this input, right at the beginning of this particular manual, there's an example program which takes you through the process of building an application in Intuition. Gosh, I love these PDF readers. They are so like, gosh, we're going to be so memory efficient. We're only going to load in the things we know we want, even though we've only got, a certain amount of memory, no problem, whatever, blah. I digress. So you have this great Amiga Intuition reference manual that was written by R.J. Michael, which explains what Intuition actually is. For a refresher, Intuition is the user interface that's built on the Amiga, and it's responsible for the things that you see on the Amiga that are window-like. What it does is it integrates all of the bits and pieces from the graphics library, from the layers library, from the input, all the various little bits and pieces of a library, and builds structures around them and abstractions around them to make them much easier to use in the context of a graphical interface. And one of the things that you can do it makes writing code very easy here. So we can start with, and one of the things that it gives you here is the first bit of how do you open a window? Creating a simple window. How do you take and communicate with the event loops, etc. So it's a very useful reference to have open here. Well, the first thing we're going to need is Intuition has what are called new structures, things like new window, new screen, etc. These structures get copied into internal structures, and they become part of the list of windows or the list of screens that Intuition manages. Well, we want to take and make a couple changes here. We want the window, this is the start position of the window, and we want it to start at the very top of the screens from 0, 0. We want it to be 480 by 200 pixels because it's 200 pixel window, 200 line window here. I want to use slightly different pins, color 0 and color 1. Well, what's color 0 and color 1? If you take a look at the color palette, you'll see color 0, 1, 2, and 3. See? So you can use that as a reference. We want to switch, basically we want to use the correct pins here that are normally used by Workbench programs here. So color 0, color 1. And we want to go ahead. There are a few things that we want to be able to deal with here. We're not going to really deal with, there are no gadgets in this window that we're going to make, so we don't really deal with that. We don't need to deal with gadgets here again. We're not going to track any mouse buttons. There's no menu pick that we need, but we do want a close window event. Cool, right? Okay. And we want, these are IDCMP. Now, IDCMP, again, is referenced in the Intuition manual. And these are basically the events that you want to be, that you want your main loop to be able to catch. And in our case, we just want, we want everything to appear like it comes from its own coordinate space. So that's give me 0, 0. We want all the window gadgets. So we can, of course, do a define here, but I will take and list them out. I want to be able to drag the window. This will give it the racing stripe so that you can drag the window. Apologies here. Window drag. I want window depth so you can move it in front of or behind windows. I want a window close. I want to activate the window when it is placed on screen automatically, so I don't have to explicitly focus it. And, oops, wrong key. Apologies, fellas. I'm having to press some weird keys to get to some keys I don't normally get to. So, the window close, and I want smart refresh. Now, a weird thing about Emacs here is that it will not wrap the window, so you kind of have to deal with that. We don't have any user gadgets in here, so that's null. We don't have any user check marks in here, so that's that. We're going to take and change the name of the window here to FX sign. Okay, window title. Pointer to screen. This is going to show up on the workbench, so we don't need to put a screen here. And this window is not being drawn through a super bitmap or an external bitmap, so we can basically just keep that turned off. Sizing limits, min and max. 50, 40 is fine. 480, 200. And we want it to show up on the workbench screen. Groovy, right? Okay, so there we have those bits and pieces that we know we actually need for our new window. We have an external struct here. And there are a couple of global structures that we need so that we can take and communicate with both intuition and the graphics library. These are pointers to intuition base. And pointers to GFX base. There we go. Those are now in place. We can come down here. And we can go ahead and add a pointer to our window that we're going to deal with. This is how we're going to refer to our window in our program here. We have to go ahead and just define that there's going to be a pointer here, and it's going to be created by create window. But there's a couple things we need to do. So first things first, all C programs need a main, and since this is K&R C, it's literally defined like this. No argument processing, otherwise I would put in, but we don't need it, so we're good. We're going to call a couple of things here. We're going to call init, we're going to call done, and we're going to basically just init done. For now, that's good to go. Okay. And init will be here. Done will be here. And there's a couple of things that we know that we will need to do. Okay, great. Well, what do we want to take and do in our initialization? Well, we need to be able to talk to the graphics library. So we need to go ahead and set GFX base. This is literally the address in ROM where the graphics library starts. And it's a pointer to all the vectors for the rest of the functions and structure, which is a structure to have to all the other functions. So we can deal with it. But it has to be defined. The system has to open the library for us and give us a pointer to it that we can deal with, because that's not hard-coded in the system at all. So what we return back is actually a pointer to structed GFX base, and we open the library, the graphics library. And the second parameter is the desired version that we want to use. Now, if you were using functions that appeared in later versions of graphics library, let's say in version 2.04 or 3.1, then you would have to set this appropriately. Say that for 2.04 or that for 3.0 or that for 3.1 and so on. But since we really don't care, we just want to grab any version of graphics library and support any version of graphics library that's in ROM, we just use 0. If we didn't have the correct version, this call would fail, and we would then not get a pointer to GFX base, which we can check to see if it's null, and then exit out of the program gracefully if that were the case. But this is okay. We can do GFX base here, and if not GFX base, we can then basically could not open graphics library, and oops. Well, that was interesting. Again, weird keyboard shortcuts that just immediately take and bounce back, so my bad. Could not open graphics library. I need to do that. Okay, here we go. Again, even my backslash is in a weird spot. So that's fine. We just take and return 0. And there we go. We have to do the same thing for intuition base. There we go. Bam. Kind of the same thing. And we'll just take and copy and paste this over here. Sure. Could not open intuition library. And that can change this a little bit. Oop. Man, these key bindings are funky. Okay. If not init. Okay. So there we go. So now we've got a little bit of some guards happening here. And now, once we've opened our two libraries that we know that we need, now we can actually start to use the functions in those libraries. Now, if you actually take a look at the includes for these particular files, again, we need to understand this. Include, hold on a second. Give me a split second here. I'm going off on a slight tangent, but I need to point this out. Just remembering where this freaking thing are. Okay, yeah, okay. No, not libraries, but intuition. Intuition H. Okay. The big intuition header file. You'll see that we're including other files here because we need to reference things in the graphics library and whatnot. But there's going to be something you're going to notice. We're going to see structures. We're going to see lots of structures. We're going to see lots of defines for all sorts of things. Structures for requesters, all of this stuff. But you're going to notice that there are no function prototypes in here at all. And that is literally because, again, K&R C, you define function prototypes if what you're returning is not an integer. Parameter passing is a lot more lax in K&R C. But there you go. That's the bottom of the intuition file. You go, there are no function prototypes. So if we now go back to our buffer, we can now take and build our structure, struct window, and open window. We can open our window. Pointing to our NW sign. And in fact, if you look in the example here, it's pretty close to what we're doing here, except we're just doing it out of band. So struct window, open window, new window structure, which gets filled in. In our case, we statically allocated it up in BSS, so we don't have to do all this up here. But there we go. We can do that. And we can then, now that we've got this basically set up, we can do another little check here. So hold on. There we go. Could not open window. Again, return 0. And that's all our initialization routine has to do. Now, if we actually run the program right here as it is, we'll do a few things that aren't quite right. One of the things is we need to take and make sure that we close our libraries and things out that we use. We need to close our windows. We need to take and again, wsine. We need to close our libraries. And we're done with that. But we also want to do a tiny little bit of event processing here. Init, okay, return 1, fine, at which point we then take and have our little main loop. And all we really need to do at this particular point in time is do a wait. In fact, we'll just wait for a single intuition message that come across to deal with deal with a closed window, whatever, doesn't really matter. And then if we receive it, we'll take and close the result. So we have wait 1, and the way you do this canonically is you wait for a particular signal to come through, and that signal comes through on a number of signal bits. The way that messaging is actually implemented in Intuition, as we find out if we dig through the Intuition manual here, is that it uses the message ports that are built into exec to take and send all sorts of information, and usually these are in the form of signals for events through the user ports of each individual element in Intuition. In this case, we want to see if something happens to our particular window. So we have our window sign, which we have opened up. We want to access its user port, and we want to look for its Windows signal bit to indicate that there's a message waiting for us. And after that, basically done. In fact, we can basically just go here. If we save the file here, we'll go ahead and go over. Workspace sign. Now we have our little make simple script, which has been copied into my scripts folder, and we'll take and build this goofy thing. Of course, I mean, we can actually start, while this thing is building, and start building onto other bits and pieces as well. Let's start thinking about our routines that's actually going to take and do our window drawing. Well, we want our window to have kind of this little legend or a grid, some dots on it so we can see things nice and easy. So let's go ahead and draw that. In fact, I'm going to take, to speed things up just a little bit, we're going to take and pull this in from my other buffer here. We're going to insert my backup. Okay, disk is there. Let's go in and next to XV. We have 0, sine.c. Let's have a look at it. Oops. Did I just? Yeah, I did. Oops. My bad. Hold on a split second. Okay, slight little glitch here. We'll take and open up Emacs again and do a little change here. Again, using run to make sure we do this in the background. And we're going to take and do, yeah, NWSign. So there's NWSign. Okay. Oh, no. I copied this over, so let me take and fix this. Save. Okay, great. Now we're going to take and do a little bit of, we're going to visit another file. Let's see where this file is. It's not on df0, but df1. Yeah, that's what happened. Okay, so we're going to take and split some of the screens here, just kind of get this prepared. We're going to start the compile again and do this while we're actually taking and putting in the next bit of code. So here we go, back in. Here we go. Da 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 da. Oh, come on. Don't tell me Emacs is frozen here while this is happening. This usually doesn't happen. Let me see. Windows are okay. I guess. So there we go. Okay, linking. If Emacs starts moving, I'm going to laugh. MicroEMACS seems to be a little bit. Maybe if I put it on a separate thread. Here we go. It never fails. I mean, anytime you take and do rehearsal of all these things, you can still always have glitches. I spent the last few days basically putting all of this together so we could do this. Boy, this linker sucks, and I have forgotten how much it fucking sucked. But I think we're at the end of it here. Yep. So, okay, done linking sine. And if we run sine, we see our window right here, ready to go. And it's just bouncing around, responding to events, etc. Okay, and closing causes the program to take and exit. Okay, we're good. We have our intuition window. Now we can actually start doing things with it. Let's see. So let me go back into, I'll just run this as a, I'll do this as a, in a completely separate frickin' context and just keep this guy open. PD workspace sign, Emacs. sine.c. Just kind of keep this on the side here. Okay, so now that we've got this, now we can actually start putting in the bits and pieces that we know we want to put in to take and draw our grids and things. Sure, no problem. We have our init and done. And now we'll take and visit a file and df1 sine.c. Actually, let me just do this in a separate window, do this in a split window. Okay, see, because these all both had the same name here, MicroEMACS helpfully said, well, you want to take and differentiate the two of them? Yes, I do. I want to take, and I just gave it a different buffer name so we could deal with it. I'm going to look for the grid function, which I've added here, and we're going to take and pull it over pretty much wholesale. And you can see that it's basically a whole set of functions to basically take and set a block pin so that we can set the A pin so we can draw with a particular color that we want, a pattern that we want. And we draw the zero crossing line and all the legends and all the text that goes along with it. Escape W, okay. And now we come down here and we'll yank it right into place. And we'll call it. Okay, go ahead and call it, and we'll build again. We'll just put you to the back. There you go. Execute, make simple. Make simple sine. And while that's happening, we'll go ahead and see if we can do the next one. Here we go. Yeah, okay. It's acting a little better now. All right, so there we go. So now that we've got that, now we can come back and we'll add in the next little bit here. Our little function to take and display a sine wave. You'll see up here in the top with all the drawing routines, they all pretty much have the same calling convention. So these are the functions in the graphics library that get called in through GFX-base, and they are things like move and text and draw, etc. They all take as their first operation, as their first parameter, the raster port. Whenever Intuition takes and manages a particular window, it provides a pointer into the drawing area for a particular element. In this case, it's a window, so there's a raster port for that window here, and pointing to that raster port allows you to draw inside of that window. And then, of course, we have coordinates after here. So much the same thing here. But here, we're going to use that to take and display our sine wave. We've already taken set our mark. We've taken copied, come over. And we've got the next bit of what we want to do here. We take and do it. Okay. And we'll see how we're doing over here. Okay, almost done. The power of multitasking, fellas. So even though you've got certain things that are taking a while here, you can take and go off and do other bits and pieces of what you need to do and try to maximize your time. So now we have sine, and with this we should see our little grid area that the sine's going to sit into, along with the zero crossing here. Now I'm going to show you something kind of interesting. We've got this window here, and we can see Intuition is managing this window from front to back here, no problem. And because we've got Smart Refresh here, Intuition is actually taking care of doing the backing store for this window dynamically. That means if I put a window in front of it and then pull it back, I don't have to call a refresh event for that window to come back here. Intuition is taking care of that automatically. This is in stark contrast to Windows systems of the time, where you would have to explicitly, in all cases, keep track of whenever Windows would take and pull in front of or behind of certain things, and then basically figure out which parts of the window were damaged and refresh them. Now, Intuition actually does have these facilities available for simple refresh windows and for smart refresh windows, so you can refresh parts of the window that change. Or, for example, if this window had a resize gadget and you resize the window, you would have to take and pull it back. You would have to take and do a refresh there. But with this particular instance here, we've got pretty much we've pretty much got everything here. The Intuition's taking care of a whole bunch of things for us. So now that we've done that, we've saved that. Let me go ahead and make sure that that's saved. And we can do again. In fact, I should have been doing that here while this was being rendered here. But that gives us the opportunity to take and implement the event handling that we want. So now with that, okay. Compiler is just on its merry little way. We need to take and modify our main loop ever so slightly because we want to explicitly deal with close events correctly. To do that, we just need to replace this wait a little bit with a while statement. Or wrap it in a while statement, rather. And in point of fact, we really should be doing a double while statement with this get message that we're doing here. But since we're only going to be receiving one message for close window, we can get away with this for this particular program. Okay. Yeah. So let's just change this a little bit. So basically what we're doing here, we're waiting for a message to come through, which is being signaled. Okay, great. Then we take and quickly define a pointer to a message. We get that message from the user port and we reply to it and say, we got it. Okay, great. Boom. And so the message port is cleared and another message can come down the line. And we check really quickly what that message class is. There are a whole bunch of different message classes for all sorts of things, such as when the window is closed, when the window is resized, is there a key press that came through? Basically, all the events that we specified above in NewWindow let me go all the way to the top here. All the bits and pieces that we specified in NewWindow that we wanted to catch. Well, as it turned out, the only thing we really wanted And our IDCMP flags here was close window, so that's the message we're going to get. And if that message is equal to close window, then we take and break out so that we can immediately call done to close the window, close the libraries, and we're done. So now that we've got sine here, basically in here, sine's done. Let's have a look and see what we got. Okay, fine. One more time, and we'll just take and save it. Write the file out. We're calling sine, so now we're calling our little plot routine. And we will take and build one more time. Rest assured that as I get into the rhythm of things here, I will be a bit more staggered with my multitasking output here. And I'm doing it kind of in this way to show basically how one gets better with the environment as we go along, just like you would in reality. Oop. Undefined identifier pi. We need a couple things here. So while this is, I'll fix this right here. Basically, we're just missing math.h. That's an oops. We'll go to the top of the file. Escape. Okay, so escape. Yeah, got it. And we'll just add math.h. That's what we gotta do. We're missing our floating point functions and some constants. Got it. Boom, save. Okay. See if there's anything else I know I want to put in here. I don't think so. I think that's pretty much it. Yeah, okay. I think we should be good now. Telling you, B-Link couldn't come soon enough. Now, one of the things that we may want to be able to do once we build our application, we may want to be able to take and draw a particular icon so we can launch it very easily. You've already seen how basically launching from here or launching from the CLI here, it's one of those nice little quality of life things that you can do. We've got an icon for sine.c, and I think that's just a warning. That's fine for what we're doing. It's not going to affect us. But we want to take and make a little icon. So we can use the icon editor in the system folder. Notice this is all happening with the compile happening outside, and we will take and borrow this icon here for the icon editor for our little program just to prove the point. And for that, we're just going to do a quick little Topaz 60, Topaz 80, sure, sine x, gem 2, and we're going to use position. We're just going to, actually, let me change that a little bit. Not sine x, but yeah, we'll just do that. Fuck it. Yeah, that works. So we'll take, all right, fine. We'll just do that. Then we'll take and save it to disk. We'll save the data in our workspace folder. Workspace, sine, And this is just sine. Like that, save and frame. Boop. We have to frame it because we don't want the whole window here to be our icon. But that's okay, we just kind of do this. Boop. Saved. Now we're done. We're done with the icon here, and that will be done just in time for the link to finish. But now when we reopen our sine folder here, we'll see that we have a nice little icon for our application. Something we can quickly run. Linking complete. And if we run the program now, we have our little sine plot. And you can see it's running and it's multitasking quite nicely. Nothing too special here. It's just doing its thing. We can move windows in front of and behind and move and bounce things around, and it's none the wiser. Intuition is doing a great job of basically managing these windows. There we go. So the next time we want to do something, let's say we have MicroEMACS here, and we'll just take, we're done here with this editing session for the day. We'll take and quit. And just close off some of the bits and pieces. I'm going to take and just reboot real quick, and we'll run the program again. See, hold on. A little bit of this, a little bit of that, and there. All right, so now we've got this. Okay, go into our workbench here. We can take and do this. Okay, great. Now, of course, we can test our little program. Comes up all nice and nifty. Things move, nice and responsive. And you'll notice that recovering from exposure and, from occlusion exposure events is very fast on Intuition. It's using the blitter to its fullest effect to really speed up window operations. And there we go. And of course, if we want to take and open up the source code real quick, of course, we can click on it and go right into Emacs. So I'm going to go ahead and pretty much end the video here, but the next video is actually going to focus on building an application that will take and produce and visualize data that's been prepared outside. Let's say that you have heat map data from basically putting sensors on a printed circuit board, and you've output a whole bunch of temperature data across time, and you just want a good way to take and visualize it. And that's where the Amiga really comes into its own, is as a visualization workstation, because the graphics hardware is very fast. So we're going to start building that application in the next video. So until next time, guys, have fun.